All right, let's get on with our first lecture of the week. And what we're going to do is we're going to finish off the factorization, and we're going to do factorization of special quadratic equations. Now, they're just special in that we have a formula that we can work with, and it can quickly get you the factors of the quadratic equation. There are 4 cases that we're going to discuss, and we're going to do that as quickly as possible. So first off, I'm going to put title. Right, and we'll start off with case 1. And case 1 is when A is equal to 1. Put that in blue. All right, and we're going to have this note here. So for quadratics of the form, let's put it as white, and I'll put this in orange, of the form x squared plus bx plus c. So for any quadratic expression of that form, we're going to have a formula that we're going to follow. We identify 2 numbers m and n such that m times n equals c and m plus n equal b. This may seem like the exact same thing like we did before, and let me just put what the factors are going to be, and you'll see why it's special, because now we have the factors will be x plus m and x plus n. All right, so it's different from before when we were finding the m and the n, because we had to find a product mn that gives you ac. But since a is 1, then we just have to find a product that gives you c but adds to give b, and it's something that you can do mentally. All right, let me give you some examples. So let's say, for example, we have x squared plus 7x plus 12, and the factors of 12 are 1, 12, 2, 6, and then we have 3, 4. And if we watch each of these factor pairs, we'll see that 3 and 4 add to give you 7. All right, 3 and 4 can add to give you 7, so you'll get x plus 3 and x plus 4, and that's it. All right, so as long as you identify the factors, you just put them in. Let's do another one that has a minus sign. So let's say example, let's say you have x squared minus 11x plus 28. So we have to find the factors of 28. Well, positive 28. So we have 1 times 28, that's one pair. And then we have 2 times 14, that's another pair. And then we have 4 times 7, that's another pair. Each one of them is going to give me 28. But I need to add them and get a negative 11. When I look at this one here, I can see if I take negative 4, negative 7, I'm going to multiply negative 4 by negative 7, and I'm going to get positive 28. So that means that I can take x minus 4 and have x minus 7, and that would be the factors of this quadratic equation. All right, let's go on to another special case. And let me just put this in blue over here, and we're going to say it's case 2. Case 2. And we're going to put the situation of a being equal to negative 1. And it's going to have the same exact process, except all we need to do now is factor out negative 1 and then apply the same process. So let me just write that out. So simply factor out negative 1 and do the same as before. All right, so example number 3. All right, let's say, for instance, you have a negative in front, and it's negative x squared plus 5x plus 6. And you are going to factor out the negative sign, as we say here. So we're going to factor out the negative sign. I'm going to put a square brackets like this. This is going to be 5x and negative 6. So everything is going to switch their signs as long as you pull out that negative 1. All right, you pull out that negative 1, everything is going to switch their signs. And then you just factor what remains inside of the bracket. So we're looking for negative 6 as the product. So we're looking at negative 1 times 6, 1 times negative 6, negative 2 times 3, 2 times negative 3. And we're looking for negative 5. And we're seeing here, if we add these together, we get negative 5. So we have minus 1. We'll just put that here. Minus 1 into x plus 1 and x minus 6. And now we can rewrite this a little bit more. And we can put it something like this. We can say x plus 1 and then multiply this here by negative 1. And we'll get 6 minus x. And this here would be the best answer to put down. All right, because we don't have the negative sign out in front of the factors here. Let's try another one just to be sure that you understand what I'm doing. So let's say example number 4, and we have negative x squared minus 4x plus 12. So we're going to factor out the negative 1. So negative 1 into x squared plus 4x minus 12. We're going to look for products of 12. So we have 1 by 12, 2 by 6, 3 by 4. We want to get a situation where we have a positive 4. So if we have a negative 2 and a positive 6 multiplying by each other, that will give us negative 12. And if we add that together, we're going to get a positive 4. So I'm going to use those as the factors, and I'm going to get negative 1 into x minus 2 and x plus 6. And I'm going to just use the negative sign on this factor here, and I'm going to get 2 minus x into x plus 6. After a while, you'd recognize the pattern that's going on. You'd factor out the negative 1 in your head, and you'd be able to come to this here and at least put back the negative 1 and reach this point here. So this here would be a step that could be skipped or done in your mind, actually, I should say. And those who get even better at it, they're able to come straight from here to here without even needing to do these two parts here where you multiply out back where you multiply the negative 1 with distributive law here. All right, it's all a matter of practice. The next case that we're going to look at is the case of perfect squares. So I'm just going to put that case out here. So let's say case 3, perfect square. And perfect square, so let me just write a note here. So for quadratics of the form of, let's see, what form we're going to have. So for quadratics of the form, let's put it back in white, orange. So for quadratics that have the form x squared plus 2dx plus d squared, or let's say the form is x squared minus 2dx plus d squared, then the factors are, and I'll put that here with this and put here, the factors are x plus a squared, or it's going to be x minus d. Sorry, this is supposed to be d. Why am I saying a squared? All right. So you can get either the positive squared or the negative squared. And let's do this in examples quickly. So say example, and this I think is the fifth one. Let's just make sure. Yeah, fifth one. Right. So we're going to do the fifth example now. And we're going to say x squared plus 10x plus 25. And what we want to do is we want to recognize that 25 is equal to 5 squared, and x squared is equal to x squared. So I'm just going to put this in brackets so you can see the number that we're shifting, right? And if we take the 5 here and the x here, and we take this middle term and divide it, we're supposed to get 2, all right? So we're supposed to get 2. So if I take 10x and I divide it by 5x, x into x1, this into this 2, and this means 2. So as long as I get that 2, I recognize right away that yes, this has this form, and I can just simply put this as x squared, sorry, not x squared, x plus 5, close bracket, squared, and that's the answer. All right. So most of the time, as you get more familiar with it, as you get more experience, what's going to happen is that you're going to do all of this in your brain, and you're going to just put this out here. All right. So let's say, for example, number 6. All right. Example 6. Let's say we have 9x squared minus 12x plus 4. And we want to recognize that recognize that 4 is 2 squared, and we have that 9x squared is 3x squared. So notice that we have 2 and we have 3x. So let's go and do the division now. So we have negative 12x divided by 2 into 3x, which is just simply 2 into this is 6, and 3 into 6 is 2, x into x, 1, and we get negative 2. So that means negative of whatever is there. So here we have x minus, and then we put these, well, oh, I made a mistake. Right, so I'm supposed to put the x part, so the 3x, so I'm going to put that here. Then we have a minus coming from this, so negative, and then we look at the next number, which is the 2, goes here, and that's the answer, squared. All right. So as I said, as you get familiar with this process here, you do it in your head really quickly, and you'd be able to go straight from this line to this line. It's just a matter of practice. As long as you get enough problems to practice, you'd get that familiarity. Let's go on to the next case now, and this is the final case that we're going to be looking at, case 4. So case 4, and this is difference of squares. All right, we're going to put that in blue, and then we're going to start here. So for quadratics of the form of, use this in pencil, a squared x squared minus b squared, the factors are, let's put this here, here, so the factors are, pencil here, the factors are going to be ax plus b and ax minus b. All right, let's do some examples really quick, and that should explain any issues. I think that's 7. Yes, that's 7. All right, so we have here x squared minus 16. So we recognize that x squared is equal to x squared, and 16 is going to be equal to 4 squared. So once we recognize that, then the factors are, open bracket, x plus 4 and x minus 4. So notice it's the same x here, the same 4 here. We just put one with plus, one with minus. That's it. Let's do another one. Let's say, for instance, we have a bigger one. Example 8. Bigger one, bigger one, bigger one. Let's say 25. 25x squared minus 36. And we say recognize that recognize that 25x squared is the same as saying 5x to the second power, and that 36 is equivalent to 6 squared. All right, so we're seeing that this is 5x squared minus 6x squared. Sorry, 6 squared. And that would mean that our factors are 5x minus 6 and 5x plus 6. All right, so those are the only ones that you need to be worried about right now. Okay, sometimes you might have a combination of these special cases that you would have to work with, but again, all of that comes with practice. So from there, I will just give you some problems to try, and you can go ahead and try it on your own. So problems. And we're looking at, let's see, x squared plus 2x minus 15, x squared minus 13x plus 36, minus x squared plus 9x minus 18, minus x squared minus 2x plus 15, x squared minus 14x plus 49, 4x squared plus 20x plus 25, 49x squared minus 81, 4x squared minus 9y squared. Right? Now, every single one of these special cases can also be solved with the previous factorization method that I showed you, right? Every single one of them can be solved with the previous factorization method. The only thing that might cause you some problems is this one, but you just simply have to recognize that this is x squared plus 0x minus 16. And if you use the previous method that I showed you for factorizing quadratics, this would be not a problem for you. X minus 36. All right? So you can try it with the other method, the previous method I should say, and you would realize you get the same answers. You can verify every single one of your factorization answers by multiplying them out and confirming that your answer is correct. That's it. I'll see you tomorrow for the next lesson.